You should be able to read and write in Python after watching this video, even though you have no idea what Python is right now. In this Speedy Python Basics video, I'll go through 9 topics that I think everyone should go through when they try to learn Python fundamentals. Those topics include environment setup, data types and variable, console input-output, arithmetic operation, condition, branching looping function, and object. That's all. Starting with environment setup, there are only 3 steps that you need to do. The first one is to install Python on your computer. The second one is to install the IDE. IDE is the software that can help you to write Python inside. The one that I'm using right now and you are seeing right now is PyCharm. But you are also able to use Visual Studio Code, Vim, or anything else that you like to use. Once you are done installing IDE, you can set up the IDE so that it will be easier for you to write Python inside. I won't go into too many details since this is the Speedy Python Basics. I recommend you to watch my previous video on those 3 steps. There are 4 primary data types in Python. They are string, integer, floats, and boolean. Strings are the text surrounded by single quotation marks or double quotation marks. If texts are surrounded by 3 single quotation marks or 3 double quotation marks, that's the multi-line string in Python. And if you add an F letter in front of either one of the strings, you got an F string in Python. F string is the format string in Python, which I won't able to cover in this video, but highly recommend you to learn it in a future video. An integer in Python is a number that is not decimal. A float in Python is a decimal number. This 20.0 is also considered as a float number in Python. Boolean represents 2 possible values, either be true or false. There is also a special value which is none in Python. It doesn't belong to either one of the 4 primary data types. It just represents there is no data. All other Python advanced data types like the list, tuple, set, and the dictionary are formatted by those primary data types. I won't able to cover the details of those advanced data types. You only need to know they can store a group of data no matter what the data types of the elements are. The list and tuple can keep the order of elements, the set and dictionary cannot. Elements in a list could be changed, but a tuple cannot. Set only store the unique value in, dictionary stores the key value pair. Creating variables in Python is easy. You just need to pick up a name for it and assign a value to it. You can use all the alphabetic letters, both in capital or small letters, plus the underscore symbol and the 10 digits. But you are not allowed to start a variable name with a digits in Python. Console input-output in Python is very easy. We just need to use 2 built-in functions, the input and print. To grab an input, we just need to type in input, brackets, and inside the bracket we can type a string. That will be the prompt information. For example, here I can say enter your name. So when user our program and it sees this, it knows that the program wants them to enter their names. So once you grab the console input using this method, we can assign the value into a variable. For example, here I just created a variable that called name. And that's how you grab the console input and assign to a variable. Now we can output whatever that is stored inside the variable onto the console as well. So we can use print, brackets, and inside the bracket we just type in whatever things that we want to output to the console. Here I want to print whatever value that is stored in this variable name, so that I'm going to print the variable name. Now let's right click and click on run. See what happens there. It just prints out the prompt information there, says that enter your name, so that I know that it wants me to enter my name there. So I can type in my name. Once I hit enter, it just prints whatever I type in there and prints out on the screen. So that's how you do console input and output in Python. It's super easy, isn't it? There are 7 arithmetic operations that you can do in Python between two numerical datas. They are addition, subtraction, multiplication, division, floor division, modulars, and exponents. Starting with the addition, what we can do is we can type in a numerical data plus another numerical data. Alright, here I'm gonna put a print around it so that later when we run this, we're gonna print out the result of this addition. Alright, for the subtraction, we can type in a numerical data minus another numerical data. And for multiplication, we can type a numerical data times another numerical data. For division, what we can do is we can type 5 and then divided by another numerical data. Here I use 5 divided by 2 as an example here. When doing a floor division, we can do 5 floor division by 2. Okay, so the only difference compared to the division is that it has 2 slashes in here. For modular, we can do 5 percentage sign by another numerical data. Here, this is representing 5 mod 2. And when we are computing a exponent operation, we can type in numerical data star star to another numerical data, and this stands for 2 to the power of 4. Alright, so that's all 7 arithmetic operations that you can do in Python. Now let's run this Python script and see what is the result that we got. Alright, so starting with the first one, which is the addition, we use 10 plus 10.5 and it should equals to 20.5, and here we got the result printed out in here. And the second one is subtraction, we use 10 minus 2, which should equals to 8, and it's printing out in here. Right, the third one is multiplication, we use 5 times 2, which should equals to 10, and it's printing out in here. And the fourth one is the division, we use 5 divided by 2, which should equals to 2.5, and we got the result in here. For the floor division, we use 5 to the floor division by 2, and the result should be 2, and since it's stepped down from 5 divided by 2 to the closest integer, which is 2, so it's been printed out in here. Alright, so for the modular, we use 5 mod 2. This gets the remainder of 5 divided by 2, which should be 1. It's been printed out in here. And the last one, the exponent, we do a 2 to the power of 4, which should equals to 16. And it's printed out at the last and there. Right, so that's the result. And this is the 7 arithmetic operations that you can do in Python. Condition is a statement that could result in Boolean value, either be true or false. In Python, we can use a comparison to form a simple condition. We can also use Boolean operations to train multiple comparisons as a complex condition. There are 10 types of comparison we can do in Python. They are equals to, not equals to, greater than, greater or equals to, smaller than, smaller or equals to, is not, in, and finally not in. I have 10 examples here. They are all the comparison that we can do in Python. The first one is 10 is equals to 15, and we definitely know that's not true, so the result of that comparison is false. And the second one is 10 is not equals to 15. This one is true, so the result of this condition will going to be true. Third one will going to be 10 greater than 15, which is false. Fourth one is 10 greater or equals to 15, which is false. Fifth one is 10 smaller than 15, which is true. And the sixth one is 10 is smaller than 15, which is true. This seventh one is using a new built-in function, which is trying to detect what is the data type of the integer 10 in here. And it definitely belongs to an integer in Python. So this statement is actually true. Then the next statement, the type of data 10 is not an integer, we're going to become false. And the last two are going to be A is in ABC, or A is not in ABC. So A is definitely in the string ABC, so A is the substring of ABC, then this condition will going to become true. So the next one will going to become false. That's all 10 comparisons we can do in Python, and they can be used to form a simple condition in Python. We are also able to use Boolean operations and or not to form a more complicated condition in Python. For example, here, if we are using AND operation, we can join two conditions in here, so the left-hand side condition and the right-hand side condition. If both of them are true, then the final result in this AND operation are going to become true. If one of them is false, for example, here, the right-hand side 10 smaller than 5 is false, then the final result of this AND operation will going to become false. If we are using OR operation, we only need one of the condition in the left-hand side and right-hand side to be true so that the final result is going to be true. Only when both left-hand side condition and the right-hand side condition are false, then the final result is going to be false. So that's why the first OR operation here we're going to end up with true as the result, and the second one we're going to also end up with true because one of them is true, which is left-hand side. And for the final one, the third one, the third OR operation in here, both left-hand side condition and right-hand side condition are false, so the final result is going to become false. Finally, we can also use a negation operator in here, which is not, so that we can negate a true condition, so the final result is going to become false. For example, the first not true will going to lead to the result false. And here, the second one, we have a condition which is false. That is states that the 10 is smaller than 8, which is false. But if we apply a negation in front of it, then the final result of this will going to become true. So that's all the conditions in Python, and let's run this condition.py Python script so that we can check what is the result of all those comparisons. So the first one, 10 is equals to 15, which are going to be false, which is printed out in here, and the second one is true, which is in here, and the third one is false, we're going to be here, and the fourth one we're going to be false, which is here, and the fifth one is true, so it's true in here, and the next one is also true, so it's going to be true in here, and next one is true, and we're going to be true in here, and next one is false, so it's going to be false in here. So next one is in ABC, that is true, so it will going to be true in here. A is not in ABC, we're going to be false, so it's going to print out false in here. Alright, so for the Boolean operation, the first one should be true, so which is true in here, but the second one is false. That's what we are expecting. And the OR operation, the first OR operation is true, the second one is also true, the third one is going to be false. That's what we are expecting. And finally, the negation here, not true, going to become false. So that's what we are expecting in here. And finally, this is not false, so it's going to result in true, which is printed out in here. So that's all the Python condition that you need to know for this moment. Branching could be achieved using if-else statement in Python. This time I'm going to create an example trying to explain everything for that. So before I start, I would like to explain a little bit the codes that I already have on the screen. So the first line here, we're using input function to grab the user input from the console, and here we have the prompt information says that it needs to enter an integer. So this is trying to let user enter an integer. Once we got user enter an integer, then we store whatever the user inputs into the variable that is called input integer. But before we convert it into integer in Python, it's actually in the string data type. So we need to convert it into integer in the next line, okay? So that's what we do with the code that we have in here. After that, we can create if-else statement. To create a if statement, we just type in if. After if, we just need to type in a condition in here. So we can say if input integer is greater than 10, that's actually one condition, okay? If this condition is satisfied, we're gonna run whatever inside the if statement scope, okay? And now I can say if this condition is true, then I'm gonna print, okay, this is the start of the if statement scope. Okay, so this is first line I would like to print, and the second line I would like to print is the input integer is greater than 10. Okay, so I have 2 lines now. I would like to print the third line, and this one is the end of the if statement scope. Alright, so now we successfully create a if statement in here, and also we create an if statement scope. So as you might notice that these 3 lines have a common thing, which is they have some spaces in front of their lines. So this is actually the indentation, and they have 1 indentation. So in here I set 1 indentation equals to 4 spaces. So all of those 3 lines have 4 spaces in front of them, and that means they are 1 indentation to the right, and that means they belong to some kind of scope, and here they are belongs to the if statement scope. Alright, so now if you want to have another condition, you can use an else if and following another condition to have another else if scope. So you can say if input integer is smaller than 3, then you're going to run whatever inside this else if statement scope. So you can say this is the start of the else if statement scope. Okay, and now the second line I would like to print the input integer is smaller than 3. And finally, the third line, I would like to print the end of the else if statement scope. Alright, so if none of these 2 conditions is satisfied, then you're going to go into the else statement scope, which is here, and we can print out something. And this time I don't want to print out 3 lines, I only want to print out 1 line, and I can say the input integer is between 3 and 5. Okay, so once I'm done, I would like to go out any of the scope and then print out this is the end of branching example. Alright, now we just successfully create an example of branching. So here we have a block of if-else statement in here. So that is from line 4 to line 13. And this is a set of if-else statement here. And let's take a look what will Python interpreter trying to do when it runs this Python code. So first thing, we're going to come in and trying to see if the first condition is satisfied. If it is, then we're going to go in this if statement scope to run whatever codes inside, which is the line 5, 6, and 7. Alright, but once it's done, you're gonna finish and you're gonna not run whatever inside the else if statement scope or the else statement scope. Okay, and if this condition is not true at the very beginning, then you're gonna try to see if the second condition is true. If it's true, you're gonna go in and run whatever inside the else if statement scope. But if it is not true, then you're gonna go in and run whatever inside else statement. Okay, so only one of the scope in this if else block we're gonna be execute, and once it's been executed, we're gonna go ahead run whatever after this if else block, which is the line 16 in here. Right, so that's basically how if else statement is working in Python, and that's how the branching is working in Python. So let's run this Python script to see what is the result. Alright, so it just gives us a prompt information, so we can type in a number in here. So let's type in 15, which is greater than 10. So what we're going to do is we're going to go into this if statement scope and run line 5, 6, and 7. Then you're going to finish. So you're going to jump to line 16 and run this. So let's hit enter and let it run. And as we can see here, it prints out 4 lines. So the first line, it says the start of the if statement scope, which is the line 5, and the second line that it print out is the input integer is greater than 10, which is line 6, and the third line to print out is the end of the if statement scope, which is the line 7, and finally the fourth line is the end of the branching example, which is the line 16. Okay, so now if we rerun this Python script, and if this time we type in an integer that is not greater than 10, instead it's smaller than 3, then we're going to try to run the else if scope, which is printing out this 4 lines. So it says the start of the else if statement scope, which is line 9, And the second line they print out is the integer is smaller than 3, that's line 10. And the third line they print out is the end of the else if statement scope, which is the line 11. And finally, the fourth line is also the line 16. Okay, so this is making sense. So now let's run it again, and this time will be the final one. And let's enter an integer that is between 3 and 5. Let's choose 4. And this time it will only print out 2 lines. And the first line they print out is the input integer is between 3 and 5. That is actually the else scope, which is line 13 in here. And after that, they print out the end of the branching example, which is line 16. All right, so that's basically how the if-else statement is working, and that's what the branching in Python. Now you know some Python and you can write some Python code, but if you want to repeat a certain Python code, what you are going to do is copy and paste them multiple times. This is not a good practice. So a better practice is to use a for loop to do that. There are 2 options of looping in Python. They are for loop and while loop. Using a for loop, you can specify the number of iterations that you want to repeat for a code block. For example, if you want to repeat a code block for 4 times, you can do for I in range 4 colon, and you can type whatever code that you want to repeat for 4 times in here. For example, here I just put in print this is Speedy Python basics, and you're going to print 4 times. And let's try to validate this by running this Python script. And as you can see in the output under the for loops, and you're going to see this is Speedy Python basics being printed out 4 times in there. You can also apply a operation to all the data that is stored inside a data collection in Python. For example, if I have a list, that is a data collection that stores a bunch of integer inside, and I can use for loop to apply an operation to all the elements inside this A list. So I can type for data in a list colon, and I'm going to start apply the operations. So the operation I'm going to apply to all the elements inside is I'm going to print the data on the screen. Okay, so this is actually printing all the elements that is stored in a list. So now let's run this Python script and see what is the result. And as you can see here, after this is the Speedy Python basic, which is the example that we ran before, and you're going to print out the number 1, 2, 3, and 4. So basically it's applying a operation to all the elements that is stored inside a list. Right now here it just print out the contents of the element. So you're going to print out 1, 2, 3, 4 on the screen. So next, the while loop. While loop allows you to repeat a code block until a condition is no longer satisfied. So in order to use a while loop, you need to have a condition. So in order to create a condition, I would like to create a variable named iterations. And I'm going to assign value 4 to this variable iteration. And next, I can create a while loop after this. To create a while loop, you just need to type in while following a condition. And here, I would like to create a condition that is iterations is greater than 0. Okay. When this condition is satisfied, you're going to run the while loop scope, which I want to print. This is the Speedy Python basics inside this while loop scope. And at the end of this while loop scope, I would like to update the variable iteration. And I would like to reduce the value by 1 in this variable iterations. So eventually the iterations were going to become 0, and that we're going to not satisfy this condition, and the while loop will going to stop at that time. Okay, so at the end, I would like to print something so that I know it's actually jump out the while loop. Okay, so I'm going to print this is the end of looping example. Okay, so now it's done creating a while loop. So let's run this Python script and take a look what is the behavior of it. Alright, so now under the while loop, that is the behavior of the while loop. What happened is, what we see there is, it prints out this is the Speedy Python basics for 4 times. That means it runs the while loop scope for 4 times. And that's actually what we are expecting because we set the iteration to be 4. And each time we just update this variable iteration, we reduce it by 1. And eventually, after 4 times of running this while loop iteration, it's going to become 0. And that means this iteration greater than 0 will no longer satisfy. And the while loop, we're going to terminate it. And you're going to run whatever behind, which we're going to print out. This is the end of the looping example here. Alright, so that's how to use the loop in Python. You have 2 options, either use for loop or while loop based on your need. Function is a block of codes, and it only be run when it's been called. User is able to passing in the argument into the function when they are calling the function. And function is able to return a value at the end so that it will going to become the result of that function. Functions is very good in a use case if you want to run exactly the same code block multiple times in multiple places in your code base. Here, I'm going to create an example function that we're going to do the calculation of the factorial numbers. To declare a function in Python, what you need to do is to type in def, which stands for define. After def and space, you will need to pick up the name of the function. Here, I'm going to name it cal factorial. After the function name, you need to type in a parenthesis. And if you want user to passing down any argument when they call the function, you can specify the argument in here. And here I would like them to passing down an argument which is the n number they want to calculate the factorial for. Once that is done, just move your cursor all the way to the right hand side and type in a colon at the end of this line. Just hit enter, and next we need to declare the codes that you need to run when someone calling this function. Here I want to do the codes that we're going to do the factorial calculations. I'm going to create a variable that we're going to name the result, and I'm going to assign the initial value 1 to the variable result in here. After this, I'm going to use a for loop for I in range starting from 1 all the way to n plus 1, and each step size is going to be 1. And inside this for loop, I want to do the factorial calculation, and I'm going to use the result equals to result times I. If you can understand the calculation of the factorial, you know that after this for loop, we are able to calculate the factorial of the number n. So now I have the result, so I just need to return the result in here. That's how you declare a function in Python. But if you run this Python script right now, nothing will gonna happen because no one is calling this function. So in order to let the code block run, we have to call this function. So to call this function, we need to type in the function name, which is the cal factorial, and following a parenthesis. And if your function needs a parameter to run, then you need to passing down an argument in here. So this calc factorial, we're going to require one parameter, which is the number n. So I'm going to passing down a number 5 into this function. Once it's done calculating everything inside the function, you're going to have a result and you're going to return the result. And we can assign the result into a variable that I just created here, name it r. Once that is done, we can print value that is stored inside the variable r to see what is the value there. Alright, so now if we run this Python script, we're going to go in and see, well, there is a Python function declaration here, but it won't run immediately until line 9. So you see the function has been called in line 9, so that we're going to go into that function and run whatever the code blocks inside. Once it's done, we're going to return the result that is calculated inside this function and assign to variable r in line 9. Okay, so now let's run this Python script to see what is the behavior of it. Alright, now it's been run and we see there is a number be printed out on the standard output, which is 120. And that's exactly the result of the factorial of number 5. So that's how you define a function in Python and how you call a function in Python. Talking about the objects in Python, actually we already use a lot of objects in this Speedy Python basics. In general, if you create an instance of any Python's data type, then that instance will going to become an object. This includes a string, an integer, a float, and a boolean. It also includes a list, a tuple, a dictionary, and a set. But sometimes we're going to find that the Python built-in data type is not able to cover your requirements. So that's the time you need to create your own custom class. To create your own custom class, what you need to do is type in the keyword class following the name of that class. For example, here if I want to create a person class, I'm going to type in person in camel case. And each custom class, we're going to need a constructor method. To create that, just type in def in the person class scope and type in init. Here we need to use a self as the first argument in our class method. If you want user to give in some information when constructing this person class, then you will need to specify in this construction method. Alright, so for example here, when you are describing a person, usually you're going to have his name, and you're going to have his weight and height. So these are the 3 information that I need when I construct an instance of class person. After that, we can create attribute to store those information. Creating attribute, you just need to type in self.attribute name here. And I'm going to create 3 attributes for this person class. They are the name, weight, and height. And I'm going to store those information that is passing in by the user that is construct this person instance. Okay, so here if you have this construction, then you have successfully defined a class in Python and we can start using this class. So we can construct the person object by doing this. We just type in the class name following a parenthesis, and inside the parenthesis we need to pass in the information that it needs when we construct the person. And here we need 3 information. They are name, weight, and height. So we're going to type in a name, and this we're going to be Alex, and the weight of Alex going to be 80, and the height of Alex going to be 180. Alright, so that's one of the objects that we just created, and we can create another person and they're going to become the separate objects in the same class. Okay, so the second person could name John, and John's weight we're going to be 72, and John's height we're going to be 172. So here we're just creating 2 objects. They all belongs to person class. And now we can access the attribute of each person. So we can access the name of each person and print out the value. Okay, so let's do that. So let's print person1 dot name. This is how you access a attribute inside a instance. Okay, and also you can access the name of the person too. So let's print out both of their name and run this Python script to see what is the result. Alright, so now I just run it, and as you can see, it prints out a line, and there are 2 names in that line. The first name is Alex, which is coming from the person1 instance, and the person2's name is John, which is coming from here. So that's how we create a custom class and create an object using the custom class. But that's not all. We actually able to inherit a class. So for example here, we can create another class that is called student. Student is also a person, So we can inherit from person class by doing this. We can let the user passing in more informations. It also needs the name, the weight, and height. But it also needs something that is special in student, which is student number. And I'm going to say that is student ID. And if you want to let the parent class to store all the information they are shared, what you can do is you can do super, and then you can call ini, and you can passing in the name, the weight, and height. So those were going to be handled by the superclass person. After you've done this, you can store the special attribute, which is student ID. That's how you inherit another class. Alright, so now if you want to create the student, so we can say this is student 1, and student 1 is going to be a student, and then we're going to be named Alex, and the weight and height are going to be 80 and 180. Alright, so now the student ID, let's make it up. Let's say the ID is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now you can print out the student name, and this is student 1's name, and also you're going to print out the person's name. And if we run this, you're going to show exactly the same result here. Okay, so as we can see, it prints out the first name, which is Alex, that is coming from the student, and we have the second name, which is John, that is coming from the person too. Alright, so that's how you inherit a class in Python. But that's not all. So actually in a class, you can specify a method in that class. For example, here, and you can see, we can add the method. Let's see, a person is able to eat. So we can let it eat. So we have a method that we're going to eat. When you will perform eats, we're going to add the weight. Okay, so we're going to update the attributes of the weight. So we're going to say we use the original weight plus 5. So that's a lot of things that you can eat. Alright, so once you have this method been defined, we are able to access this method. So basically this is a special version of the function, but it's only associated with this class person. Alright, so here, since we have this function, what we can do is we can call this function using person object. Okay, so we can call eats, and then since eats doesn't need any parameters, so we can just put a parenthesis in there, and we're going to successfully call the method eat in there. The method eats just add the human weight by 5. So if we print the person 2's weight, and we're going to increase by 5. And we can do another print before we call this method eat to see what is the difference. And we're going to delete this printing name because we don't need that anymore. So now let's run it again, see what will going to happen. So the first print, we're going to print out the weight before eat, which is 72. And the second print, we're going to print out the weight after the eat, which will going to be 5 more than before. So that we're going to be 77. So that's what we are expecting, and that's how you're using a method in a class. Alright, after you have this method, since the student is inherited from the person, so student also have access to this eat method. So we are actually able to use the student 1 to access this method. Okay, let's change the person 2 to student 1. And let's run this to see what we're going to be the result. Okay, now as you can see here, it prints out the first number 80 and the second number 85. So we definitely able to access the method eat from the student because it's inherited from the class person. And at the beginning, the student is weight 80. After eats, you're going to weight 85. So that's what we're expecting. But if you have a method that is declared in the student class, then the person object will not able to access. I will not gonna show this since this is too long in this Speedy Python basics. So that's how you create a custom class and how you use the class. Alright, so now come to the conclusion after long hours of making this video. So I briefly cover the basic Python concept in this tutorial, but I'm definitely not able to cover everything in Python. So in this Speedy Python basics, I definitely missing some important concept in Python, so you might want to learn that kind of concept in somewhere else. So one of the important concept is that the mutable and immutable, so I will leave you to learn from somewhere else since I don't have time to cover in this Speedy Python basics. And thank you guys for watching until this point. Hopefully this will gonna make your Python learning journey a little bit easier. And if you have any question or suggestion, feel free to leave a comment down below. I'm happy to answer whatever question that you might have. And yep, if you didn't subscribe, consider subscribe. If you don't have any other question, I'm gonna see you in the next one. See you.